Okay, let's have a look at a work done example. So I'm going to put a floor in, put a wee shelf in, I'm going to introduce a box, and I'm going to apply a force to that box. Call that F. Now if I apply a large enough force to that box to overcome friction, then my box will travel, and it will travel a certain distance depending on how far I shove it, and that distance will be d. And this box will then have a work done associated with it. Now how do we figure out the work done? Well, if I increase the amount of force I put in, the work done by me is also going to increase. As the distance increases that I've shoved it, the work done will also increase. So, from those two relationships, the force and work done are directly proportional, and the distance and the work done are directly proportional, which means we can form a relationship between those three things as the work done is equal to the force that I apply, or whatever is applying it, multiplied by the distance that the box or any other object travels. Let's look at an example using that shelf that I put in. So we have the box closer to the shelf. Now, what's going to be acting against any motion upwards on that box? It's going to be its weight, and that is a component of mass and gravity. So if I apply a force upwards this time, and I want to obviously get the box right up to the top of the shelf, so that distance d will be from the floor to the shelf. So the minimum force required to actually move that box up there is obviously going to be equal to the weight of that box, and that will be mass times gravity. And I can relate that to my work done function. So it will be the minimum force that I have to apply multiplied by the distance travelled, which in this case will be the height between the floor and the shelf. So let's put some numbers into this example. So again, there's my shelf and there's my box. This box has a mass, obviously, and gravity is going to be acting downwards, and I want to shift that box up to the top shelf. And there's a distance between the floor and the shelf, and that's going to be d. So how do we get the work done? Well, we know, let's say the mass is 2 kilograms, and gravity, we'll assume we're on Earth, so that's 9.8 newtons per kilogram, and distance, let's just call that 3 meters. So, the minimum force required to get that box up to the top shelf is going to be equal to the weight of the box. So that's going to be mass times gravity. So we know mass is 2 and gravity is 9.8 here. So that's going to give us 19.6. And that's newtons, remember, because weight is a force. So my work done is going to equal that minimum force multiplied by the distance. So that's going to be 19.6 multiplied by 3, and I'll get 58.8 joules. And that's how we get the work done.